Hi guys, in this video we will learn to solve a Laplace transform via its derivatives. Now let's demonstrate this with a function ft which is equivalent to t plus with sine omega t. Now in order to derive the Laplace transform of ft, which can also be written here as fs. F here is capital letter denoting the function in the Laplace partial domain. So we can derive this by taking the Laplace transform of each individual components, which are the Laplace transform of t plus with the Laplace transform of sine omega t. And to solve this, we can simply look up the Laplace transform for those two components. And this can be made possible basically because we have addition that link the two components. On the contrary, if you've been given another function which is function ft equivalent to t multiply with sine omega t, now because of the multiplication function that connects the two components, you can't simply derive the Laplace of this function by taking the Laplace of individual components. This is simply wrong. So, how do we derive the Laplace transform of t sine omega t? We can do this by basically try to get the derivatives of the function itself. So now the derivatives of ft, which is f prime t, is equivalent to omega t cos omega t plus with sine omega t. Now we basically derive this by using the product rule itself. Okay, from here we derive the second order derivatives, which is f prime prime t as equivalent to negative omega square t sine omega t plus with omega cos omega t and another omega cos omega t. So we can summarize this is negative omega square t sine omega t plus 2 omega cos omega t. Now based on the theorem of derivatives, we know that the Laplace transform of f prime prime t is equivalent to s squared multiplied with the function itself in the spatial domain minus with s multiplied with the initial value of the function when time is equivalent to 0 minus with the initial value of the derivatives when time is equivalent to 0. And when we substitute when time equivalent to 0, i.e. t equivalent to 0, we found that f naught and f prime naught are both equivalent to 0. So we can substitute these values inside here and we are left with the Laplace of the second order derivative as s squared fs. And this formula we shall denote it as formula number 1. At the same time, have a look at this function which we have derived earlier on. From here, we can try to get the Laplace transform of this function of second order derivatives as the Laplace transform of each individual components. Here, the Laplace transform is equivalent to negative omega square multiplied with fs plus with 2 omega multiplied with s over s square plus omega square and the whole thing in bracket. Now I would like to highlight here that fs is basically Laplace of t sine omega t, which we have defined earlier on, so we substitute it here, whereas s over s square plus omega square is the Laplace transform of cos omega t, which we can derive from the basic Laplace transform table. Okay, so let's just call this new equation Laplace transform of second order derivative as equation number 2. Now, if we make equation number 1 as equivalent to equation number 2, we found that s squared multiply with fs is equivalent to negative omega square fs plus with 2 omega s over s square plus omega square. Next, we group the fs on the left-hand side of the equation, and last but not least, we derive the fs as 2 omega s over s square plus omega square, and the whole thing is to the power of 2. That's it all for this video. Thank you.